Welcome back everyone. In this lesson, we will focus on single area OSPF version 3. If you remember, version 3 is the version that is used for IP version 6. OSPF version 3 is used to exchange IP version 6 prefixes and build an IP version 6 routing table. Version 3 builds 3 OSPF tables: the neighbor table, the topology table, and the routing table. So if you see, for OSPF version 3 and version 2, the tables are the same. These are the similarities between OSPF version 2 and 3. Both are link state routing protocol. Both run shortest path first algorithm. The metric is cost. The areas are the same. The packet types are the same. Neighbor discovery, how they discover neighbors, are the same. Election and functions of DR and VDR are the same. And router ID are also the same. So these are things that you have looked at in OSPF version 2. These are similar to OSPF version 3. So what are the difference? The difference is the advertisement. Version 2 uses IP version 4, while version 3 uses IP version 6. So they have different prefixes. Source address in OSPF version 2, it uses IP version 4 addresses. In OSPF version 3, it uses IP version 6. The destination address is different. You would have, of course, IP version 4 network addresses. Destination address, of course, are different because one is using IP version 4 and the other one is using IP version 6. Now, in IP version 4, the neighbor is a unicast, and in IP version 6, it uses the link local. Then we have multicast address for all OSPF routers, and we have multicast address for DR/VDR. Advertising networks, version 2, configure using the network router configuration command. So you go router OSPF and then process ID. Once you get into the routing algorithm configuration, you use network and whatever the network address. In version 3, it is configured using the IP version 6 OSPF followed by process ID and then area ID. Okay, so you have to tell them that, oh, this is IP version 6 OSPF. IP version 4 unicast routing is enabled by default, so you can just directly use it, but IP version 6 is not enabled by default. You have to enable it. You have to type IP version 6 unicast routing in the global configuration mode to enable this unicast forwarding. Authentication in version 2 uses plaintext or MD5. In version 3, it uses IP version 6 authentication, which runs on IPsec. Link local addresses. An IP version 6 link local address enables a device to communicate with other IP version 6 enabled devices on the same link and only on that link. Packets with a source or destination link local address cannot be routed beyond the link where the packet originated. It's link local. It just works in the local area. It doesn't go out of that. If you forgot what is link local in IP version 6, I would suggest you revisit the IP version 6 presentation. IP version 6 link local address are used to exchange OSPF version 3 messages. So link local addresses so they can exchange messages. Be sure to turn on IP version 6 routing. Remember, it is not set by default. You have to switch it on. And how do you switch it on? By typing IP version 6 unicast routing. So this will enable routing of IP version 6 OSPF. So how do you configure OSPF version 3? First, you enable the IP version 6 unicast routing using this command. Then you configure link local addresses. Now, if you don't configure link local addresses, it is given to you automatically. Then you configure link local addresses and you configure a 32-bit router ID. using the command router ID and whatever the router ID you want to use, 1.1.1.1 or whatever. Then you configure optional routing specifics such as adjusting the reference bandwidth. Now, optional. So if you need to do this, do it. If you don't, there's no need to do that. And then you configure OSPF version 3 interface specific settings such as setting the interface bandwidth on serial links. Again, this is optional. But if you want an optimum network, it is good for you to look into this. And lastly, enable OSPF version 3 routing in interface configuration mode. So you go to the interface and you set up the routing. How do we verify IP version 6 addresses on interfaces? Remember that link local addresses are automatically created when an IP version 6 global unicast address is assigned to an interface. However, IP version 6 global unicast address are not required. Link local addresses are required for OSPF version 3. So when you configure an IP version 6 address, a global unicast address so that they can traverse the internet, a link local address is automatically created. So within OSPF version 3, they use the link local address for exchanging information and updates. Unless configured manually, Cisco routers create a link local address using FE80::/10 prefix and the EUI64 process by manipulating the 48-bit Ethernet MAC address. Do you still remember how to do this? I urge you to revisit the IP version 6 presentation slides. Manually configuring link local addresses make it easier to manage and verify OSPF version 3 configurations. You put in your own so that you know what is going where. Use the IP version 6 address link local interface command to apply. So if you go into the interface like this, interface gigabit Ethernet 00, and then IP version 6 address, and then the link local address that you want, and say that this is the link local address that this interface is going to use. Now, if you look here, all of them use the same thing. Every interface of a router is a different subnet. So this link local and this link local will never meet. They are in the different subnet. So it is okay for them to have the same name. Use the show IP version 6 interface brief command to verify. So then you could see, oh, there you go, that's the link local I gave just now. Use the IP version 6 router OSPF process ID global configuration command to enter the router configuration mode. It is similar to OSPF version 2, except that we put IP version 6 here to tell the router that we are dealing with IP version 6. So IP version 6, router, OSPF, and then this is the process ID. Again, once you go in there, you get into the configuration mode. Okay, notice the messages that the router tell you. Okay, there's the date, and then you have a process, OSPF version 3, but you cannot pick a router ID. Please configure manually. Then you configure the router ID. So router ID 1.1.1.1. And then autocause reference bandwidth 1000, because you want to make sure that Ethernet, fast Ethernet, gigabit Ethernet are all different. So then N, and then if you want to verify it, you type show IP version 6 protocols, and then it will show you the information about your IP version 6 OSPF. So you have your router ID here, and we have the routing protocol is OSPF 10 and so on. When you want to modify the router ID, it works similar to version 2. Okay, this is your original router ID. You go in, and then you reconfigure the router ID, and then you type clear IP version 6 OSPF process so that the new router ID will be taken and used. This command is important when you are trying to change or modify your router ID. Now that we want to apply the OSPF on interfaces, we use the IP version 6 OSPF area. So we go into the interface. So this is R1. R1 has 1, 2, 3 interfaces that is being used for OSPF. Okay, so then you can assign them into the routing configuration. First, you go to the gigabit internet interface and then type IP version 6 OSPF process ID area, and then this is single area, so it's just area 0. And then go to the serial 000 and do the same thing, and go to serial 001 and do the same thing. And if you want to verify that you have done this correctly, show IP version 6 OSPF interfaces brief. So it will show you a brief look at all the interfaces of R1. Okay, so you can see here we have the interface, the process ID, the area, the interface ID, the cost, and so on and so on. Now we want to investigate or verify the neighbors. We use the show IP version 6 OSPF neighbor command to verify neighbor connectivity with directly connected routers. So here, show IP version 6 OSPF neighbor. If you look at this, it's pretty similar to version 2, right? We have the neighbor ID, the priority, the state, because it is point-to-point, so there's no DRPDR, and then we have the dead time, how long you're going to wait before you say that this neighbor is dead, okay? And then we have the interface that it is connected to. Use the show IP version 6 protocols command to verify vital OSPF version 3 configuration information. If you want to check out configuration information, use this command. So show IP version 6 protocols, we have that it is connected, and then this is the routing protocol, OSPF process ID 10, this is the router ID, and these are the interfaces that is connected within the router and using OSPF. Now that you have configured your routes, so you want to check your routing table. So use the show IP version 6 route. Now remember this, whenever you are dealing with IP version 6, you have to tell the router that you are dealing with IP version 6. If you don't say that, it will automatically go to IP version 4. So again, show IP version 6 route. Okay, and then this is show IP version 6 route OSPF, specifically just looking at all the OSPF routes. There is no directly connected here. There is no static routes here. Okay, so only the OSPF if you use show IP version 6 route OSPF. So you have the destination network, the administrative distance, the metric, and then how did you learn it, or how to go to that network. So that is the end of single area OSPF version 3. All of the configurations are basically the same except for little tweaks. If you notice, in IP version 4, it is done under the router configuration. In IP version 6, it is done under the interface. This is similar to EIGRP. So try out the examples I gave and the labs I gave, and then you can get the hang of it. So until later, goodbye.